Hi there. In this video, I'm going to show you how to perform and generate a HAZOP analysis report on fired heaters with our software. Now, first of all, I'd like to clarify that we believe the process of HAZOP meetings is a fundamental activity to ensure the safety of a site and both from a design perspective and an operational perspective. Now, our intention is not to replace the need for such meetings or such processes in any way, shape or form. Instead, our intention is for all the EPC engineers, the engineers from the fired heater vendors, site operators, managers and other site personnel to use this tool in preparation or during the HAZOP meeting itself, of course, to ensure that the bulk of the key hazards, causes, consequences and the associated safeguards have been accounted and identified. In many ways, the engineers from the EPC and operator sides are not always familiar or aware with some of the crucial hazards that can arise during heater operation. So in the very least, this tool can be used as a check from their side that the heater has all the necessary instrumentation and equipment to maximize safety, stability and reliable operation. So without further ado, let's check it out. Now, upon entering the HAZOP wizard, we can see we have the option to select which node we'd like to assess. Now, the term node is a term used in HAZOP analysis, which essentially refers to a particular line that we'd like to analyze where a particular hazard will arise. So let's start with the main fuel line node. And let's consider a high pressure scenario. Now, when I click the Run button, the program will begin to carry out the analysis automatically. I just want to clarify that the program is intelligently carrying out the analysis based on the equipment that we have installed on a particular heater. This is not a static or generic report that's been produced for trying to fit all one case trying to fit all the other heaters. This is very specific to the heater that you have on your site. So let's go ahead and click Run. So you see in a few seconds we have the report table which is produced in a typical HAZOP style layout with separate columns for the causes, consequences and safeguards. Of course, it also shows the credible scenarios for the causes of high pressure within the node, which is, as we can see here, the failure of PCV 101, PRV 201, and PRV 101. Now, PCV 101 is the main control valve. The pressure regulator, one pressure regulator valve is also shown here. There is one that is not shown, and we are directed in a note here that tells us for the full details of the heater or this line, we should refer to the PNIDs for this particular heater. This is what you can see here in the schematic above is a general overview of the line or the main section of the line. Now let's take a look at the low pressure case. So I've selected low pressure and I'm going to go ahead and click Run. Okay, so you now see all the various valves and their failure states that may give rise to a low pressure condition. Now, some of these valves listed are the individual burner valves and they are not shown in the schematic above. However, they have been fully incorporated into the program with their respective tag numbers, and that's why they are presented in the table here. Now, in addition to the listed causes, we can also see the consequences associated with the low pressure case. So for example, we have lower heat release, lower temperature inside the heater, lower process temperature. So those are very much disturbances in the processes. Now looking at some of the more safety side of impacts, we have the unstable flames, flame loss, with the potential development of an explosive atmosphere inside the heater. So those are the actually quite serious consequences as a result of having a low pressure case. Now we also have listed the safeguards. A pressure transmitter 203 on the main skid exit. We also have PT204. Now PT204 and 203 are listed in the just towards the outlet here. This PT on the outlet of the line here. This schematic is more of an abbreviated schematic as mentioned before. Now in addition, on this particular heater we also have main flame detection using UV scanners. So that protects us against unstable or flame loss and protects us against the development of an explosive atmosphere, because upon loss of the flame, that will be detected by the scanner, and then the BMS will shut down the associated valve or the respective valve for that failed burner. Okay, so that's all we have time for. This was just a very quick video just to kind of give you a little bit of an overview of the HAZOP analysis tool that we have within the program. If you'd like to try out the program on one of your heaters, or if you have any questions, or maybe you have a current project where this tool might be useful, please feel free to get in touch with us via our website heatersim.com. Thank you for your time.